Hello, good evening everyone. So I hope I am audible. So let's wait for another 2 minutes and then we'll start. Okay, so last week sir discussed about this thing about entity recognition, then linking and disambiguation about all these things, and then how you can do information extraction and what is distance supervision. Those are the things that were taught in the last week. But among all these things, so we'll just discuss about these numerical problems. Uh, I hope which are pretty easy, and at the end I will show some of the code snippets. So how you can use it in your real life. So how you can do this kind of thing. So entity recognition and then entity linking and all this thing. And I will just show some small code snippet, and then you can try those at home. Okay, so without wasting any time, so let's start about the numericals, last week assignment numericals. So the first numerical question is that the word is given C, and it occurs 600 different Wikipedia articles, and the table is given. So what does this table mean? So it is C1 means like this C is connected to some of the pages. So this C is connected to some of the pages 200 to 3 times, and some of the pages and 161 times, some of the pages 18 times. So this is the thing. So really if you just draw it pictorially, so what they are saying ki the word C has like occurred in maybe 600 different Wikipedia pages. So suppose different Wikipedia pages, so dot. So uh, so you can consider it. So C can occur in 600 times in different pages, and in suppose in some of the pages C, suppose this is the word C in here, and in a document C may be here, and some of the document C is here, and so on and so forth. And they are saying ki, some of the documents C connected to another page which is C1. Maybe in this page also C is connected to C1, and maybe this also is connected to C1. Similarly, there are other 4 such pages, C2, C3 and C4. So maybe some of the C link is connected to C2, some of the link connected to C2. So these are the counts these are the counts I've given here. So C1 is connected to the C is connected to C1 200 to 22 times, C is connected to C2 160. So these are given. Now they are asking, so what is the key phraseness of the word C? If you just remember the formula, so it is quite like easy. So what is the key phraseness formula? So how many times a word occurred, and how many times it connected to some other Wikipedia pages. Okay, so basically yeah, so basically what is the formula? So basically it is a how many times a word occurs. So it is like, suppose you can consider it is a count frequency maybe. So how many times the word occurred, and how many times the word W connected to some other Wikipedia article. So in our case it is maybe C1, C2, C3 and C4. So this is the thing. So how many times total this W present, and how many times it connected to some other Wikipedia article. Okay. So if you just see in the table, so the total number of time the word occur in the different Wikipedia article, it is 600. So the denominator will be 600, and what will be the numerator? Numerator will be the sum. So it will be the sum of this 4 terms. So C1, C2, C3, C4. So no link is not there. So only the four top 4 terms. So this thing. So it will be. So if you just get the point. So the key, I'm just writing it as also key phraseness. So maybe key phraseness of the word C. So it is key phraseness KP maybe. So it will be 600. Then the connection. So this connection. So 223 161 18 and 3. So okay. So 223 161 18 and 11. So if you just sum them up, you will get the output. So what is the thing? So let's do the calculation. So it will be 223 plus 161 plus 18 plus 11. So it will be 413 by 600. So what is this? If you divide it, you will get 0.6883, something like that. Okay. So yeah, so the C is the correct option. Okay, so if you go to the next question is again an easy one. So the same thing, if you just follow the table, same thing. Now here what they are asking is that commonness. So commonness between S and C2. So what is S? S is C and C2. So what is the commonness formula? So if you just remember, so what is the commonness between suppose this word and a connection, maybe another connection C. So what is the formula? It is the number of time the number of time the word W linked to C by the number of time W linked to all other documents, so all C dash, so all other connections. So in our case, C is connected to C1, C2, C3 and C4. Okay, so we are ignoring the no link, so no link is not considered here. So in our case, if we want to get the commonness between AS and C2, then so it will be the number of time C is connected to C2 divided by the total. So number of times C is connected to C1 plus C, and number of times connected to C2 plus C3 plus. So this is the thing. Now if you just put all this value, you will get the answer. So it will be like, what is this C2 to? It will be 161. If we just see in the table, it is yeah, it is 161, and you just need to divide it by this sum. So 223 plus 161 plus 18 plus 11. So it will be 161 by, I already done this thing, so it will be 413. And if you just calculate the value, 161 divided by 413, it will be around 0.389. Okay. Similarly, okay, so if you just check the answer, so yes, so the B will be the answer. 3B will be the answer. So similarly, you can check the commonness with so here we check the commonness with C with C2. So if we just write it in the shop, so we have check the commonness between C and C2. So this is the thing. Similarly, we can calculate the commonness with C1, C2, C3, C4. If we just remember, so why we use this commonness formula? So to disambiguate. So to disambiguate two things. So what is this disambiguating thing? So basically here, so in this question, so the word C is mapped to different Wikipedia articles. So C2, C3, C and C4. Now the thing is that why we are interested in this commonness formula. So we want to measure among these four options what is the correct. So if you want to disambiguate the word C, so with which of this article we will map it. So suppose we have a sentence. Suppose we have a sentence. In that sentence, so suppose W1, W2, Wn. So in between there is a word called C, and we want to tag and link this entity with some of the Wikipedia entity. So so in such a case, so if C is already if you just check the table, so in the table, so they are saying C is connected to C1, C2, C3, C4, but if you suppose someone give you a sentence, so this is the sentence, and in the sentence there is a word called C. Now this C, among these four options, which one will be associated with this C? So which one will be associated with C? So this commonness is useful for entity disambiguation. So then, so how will you disambiguate? So we will check the commonness with so we'll check the commonness with C1, we'll check the commonness with C2, we'll check the commonness with C3, and we'll check the commonness with C4. And so which will give me the maximum? So which will give, so among all these things, which will give us the maximum value, we'll choose this thing. So basically it's the argmax. So among this four link, which will give me the maximum value, will link this C with that link only. Now can you see, so there is a drawback with this formula, so with this commonness formula. So if you see what is the commonness formula? So commonness formula is the number of time this word is connected to some suppose we are just checking the commonness between C and C1. So then, so what is the commonness formula? C2. So we need to check number of times C connected to C1, and all others divided by the all the connections. So all the C's. So C belongs to C1, C2, C3, and C4. Now if you see the formula, so denominator is same for all the options. So denominator will be same for C1, C2, C3, C4. Only thing will change is this one, the numerator. So this value is proportionate to the number of time the word is connected to individual items. Okay, so if suppose in our example, if you just see the table, so this C1 is connected to the maximum time. So it is connected to the maximum time, to time. It is connected to 161 time. It is 18. It is 1. So if you use this formula to disambiguate, then every time it will select the C1. Okay, so it will every time it will select the C1, because see, in this case, when you are measuring the commonness with C and C1, the numerator will be the highest, 223. Okay, so for C2 it will be 161, for C3 it will be 1. So if we use this formula, it will be always choose the highest connected Wikipedia articles. Okay, so this is the problem. So it is not checking the other things, so the context and all this thing. It is just saying, okay, so number C is connected to this much number of times, so you need to select this. So this is the problem with this kind of commonness formula. But yeah, okay, so again, so last year also, so there is similar type of questions. So yeah, so the thing is just the value and the words are different, but the problem is same. So again, so they are asking same thing. So the text span X is Tokyo. So here, so in our, so the example that we have done here, the word is C, and so here it is just Tokyo, and they are saying that this Tokyo is occurs in 500 different Wikipedia articles, and same. So they are asking to calculate the key phraseness of Tokyo. So I hope you can easily do it. But yeah, so just for the sake of practice, so you can do it here only. So if you just remember the formula, you just put the thing and get the answer. So what is the key phraseness formula? So total number of time the word present in some of the Wikipedia articles, and in the numerator the number of time this word connected to some other Wikipedia articles. Okay, so if we do this thing same, so again, so the number of times, Tokyo occur in different Wikipedia articles, so different Wikipedia articles, and number of times this Tokyo connected to some other Wikipedia articles. It will connect to some other Wikipedia article. Okay, so basically, the numerator suggests that the number of time the word Tokyo connect to some other Wikipedia article, and numerator is the total number of time to this Tokyo present in the Wikipedia article. So the denominator is the frequency of the number of time it connect to some Wikipedia article, plus it does not connect to some Wikipedia article. So the denominator is kind of a regularization. So if we just see, so in our case, the Tokyo occur total 500 times. So Tokyo occur total 500 times. Okay, so among these 500, it connects to some of the articles this many number of times. Okay, so it connects to some of the articles this many number of times. So 360, 110 and 7, it is like 360, 100, 110, 360, 110, 10 and 7, 10 and 7, and rest. So and if you just check, so 57 number of times it does not connect to any other Wikipedia page. So if you just sum up this row, it will be total. The sum of this row will be 500. Okay, so if you just check it, the sum of this C1, C2, C3, C4 plus no link, it will be 500. So yeah, so it will give us. So if you just do the math, so it will give you the total values will be 116 plus 110 plus 17, so 443 by 500, so 0.886. So what is this all? If you just check it correctly, the formula is like how many times Tokyo connects to this C1, C2, C3, C4 plus Tokyo with no connection. And in the numerator it will be Tokyo C1, C2, C3 and C. Okay, so basically this is the formula. So yeah, B will be the correct answer. Similarly, same thing. So if you want to check the commonness of the word, so Tokyo with C4, Tokyo with C4, you can just check. So the total number of time it connects with some other. So it will be a fraction of two things. So in the numerator it will be the number of time it connects with C4, and in the denominator number of time it connects with some other Wikipedia articles. Okay. So it will be, so basically so commonness of Tokyo with C4, so the number of time it Tokyo connects to C4 and total number of time Tokyo connects to C1 plus Tokyo connects to C2 plus C. So I think it is 7. Just check, it is, yeah, it is 7, and in the last slide we calculate the sum, it is 443. So 443, if we just do the sum, it will be 0.01586. So this is the commonness with Tokyo with this. Okay, so they have not calculated the value, so it will be 7 by 440. So the number 4 will be the correct answer. Yeah, so the number 4 will be the correct answer. Okay, so this is about this all these numerical problems, and this short questions are not, the normal questions are easy. Basically these are directly related to the lecture, so I don't want to discuss, but if you want, so let's discuss one or two such questions. So one of the question is like, which of the following phenomena can pose a challenge to task of entity linking? So so this question is asking, so what are the problems when you are going to link entity with something? So what are the challenges you can face? So what is the option? So first option is the variation in textual representation of the same entity. Yeah, so this is obviously this is a problem. Suppose you are maintaining a dictionary, and you are, suppose, like let's look at this way. Okay, suppose this is your sentence. Okay, so suppose this is your sentence, W1, W2, WN, and so suppose there is a word WI, and you want to link this WI to some out. So suppose you already have a dictionary of all named entities. Suppose, so just for example, so all or naming entity. Here, suppose so there is a word called Delhi, okay, Kolkata, something like that. Now suppose someone writes WI as maybe, suppose this example is on, suppose this is so suppose someone write this word as Delhi, so small, so it start with small uh, uh, small words, and so first word will be small. So then if you just want to match with your dictionary table, you cannot find a proper match. Okay, so this is kind of a silly example, but I hope you will get the point. So in such cases it will be difficult to map it with the actual word in your dictionary. So this kind of thing can happen. Okay, so there can be multiple variations of your textual input in your thing. So but this Delhi and this Delhi are representing same thing. Suppose someone is writing it as New Delhi, something is same problem, you cannot match it with this thing. So this kind of thing can occur. So this is a problem when you are doing such kind of engineering. Similarly, suppose someone is using some kind of abbreviation. So without writing this Delhi, someone is using some kind of this kind of thing. Suppose if you just check, so the railway abbreviation of New Delhi, I guess NDL, something like that. So suppose someone write it like this way, so then also you cannot map it to the actual entity, because this will not match any of your entries in your dictionary. So this is a problem. Okay. And what then what is the thing? Another thing, C. So multiple entities with same name. Or again same issues. Can you think of an example? So there can be multiple examples. Suppose a word can be used in multiple sentences in different contexts. So if you just remember, the common example is the word bank. Okay, so without any context, this can be mapped to river. So this can be mapped to some kind of river bank, or maybe the financial institution. So the financial institution. So there can be two possibilities without any context. Similarly, suppose the word apple. Okay, so without any context, this can be a fruit, or it can be a mobile company. So these are the problems you can face. So these are the problems you can face if you just in such instances. So if a word have multiple meaning in different contexts, so then it will be difficult for you to map. Okay, so these are the things. So, and what is the last point? So last point is the missing attributes of entities in the database. So I hope it is not relevant for this entity linking thing. So the top A, B, C are the issues you can have with this entity linking thing. So these are the problems. Okay. Yeah, so if you just check, so this first three are the problems with this entity linking. Yeah, so again, this is a simple one question. So what is this question asking? So in the task of wikification, if you I hope you remember what is wikification. So wikification basically in a sentence. So what is wikification? So what is wikification? Suppose someone gives you a sentence. Okay, someone gives you a sentence. I love apple. Maybe something like that, apple, and yeah, so I love apple. Now if you want to map this apple. Okay, so if you want to map, so this is the entity. Suppose so this is the entity. So what is the step you want to in Wikipedia? What you do? So you actually, so if you just if you know what is Wikipedia, so basically in Wikipedia you will find lots of uh, mm, details about some of the different named entities and all these things. You will have pages for uh, each of these now named entity and all these things. Now with this wikification, what you want to do is that you want to map some of your in a sentence. So there, if there is a word, so you want to map to some of the Wikipedia article. Okay, so you want to map it to some of the Wikipedia article. So this is a wikification. But what are the steps to do that? So there are multiple steps. First you need to identify in your sentence what are the entities. So first you need to find what are the entities. Okay. So what is the next step? So what is the next step? So next step is the candidate generation. So suppose for a word apple, there can be multiple Wikipedia pages. Okay, so there can be a pages with the apple fruit. Okay, so there can be a page called apple fruit. So there can be another page with apple some iPhone or mobile kind of thing. Okay, so maybe there can be another page of apple company. There can be multiple possibilities. Okay, so I'm just writing it. So there can be multiple possibilities. So these are the maybe for after identifying this entity, so there can be multiple candidates, multiple Wikipedia candidates. Okay, Wikipedia candidates for linking. Okay, so there can be multiple Wikipedia candidates for it. Now what is the next step? Next step is that selection. So you need to select. Okay, so you need to select among all this. Maybe there are other total 5 options to link this apple. So you need to select the best article. So this stage called basically the disambiguation. So you need to disambiguate. So you need to disambiguate among all these options. So there are, so basically it's a 3-step process. First you need to identify the entities in a sentence, then you need to generate the different possible candidates to map, and in the last step you need to disambiguate among these candidates. Okay, so this is the step. So this is basically the this is the whole step. So yeah, so if you see, so what they are saying, mention detection is MD. So mention detection, so basically what I am saying, entity identification. So basically this is the mention detection. So same thing. So you need to detect the mention. So in our example, so this entity, this entity identification, basically it is the mention detection. Okay, so I am identifying all the mentions. Okay, so all the mentions of a word in a sentence. So this is the first step. So what is the next step? Next step, so next step cannot be entity disambiguation. So entity disambiguation will be at the end. Okay, so in between there will be link generation. Yeah, so there will be link generation. So basically this step is the link generation. Okay, so for each of these entities you will generate the possible list. Okay, and at the end you will disambiguate, entity disambiguate. So it will be ED. Okay, so this step will be ED. So what is the flow? Flow is first in mention detection, then you will do this link generation, and then you will do disambiguation. Okay, so this is the, so MD LG ED. So MD LG. So number option D will be the correct option. Okay. So yeah. Okay, so as we are discussing with this wikification, so let me show you one of the sites. So where you can play with this kind of thing. Okay, so this site's called called Wikifire. I don't know if you know about this site. So in this site, what you can do is that you can write any, so a code snippet, no, sorry, a text snippet. So you can write anything, and you want to, and this so in the background this will disambiguate all. So first what will this this thing do? It will find all the different entities in your text. Then what it will do, it will list out for each of these individual entities, it will list out all different possible Wikipedia articles, and at the end it will disambiguate among all these Wikipedias what is the correct thing. So the uh, if the whole flow is not clear, so let's show you a simple example. So if you see in this example, so I have put one of the recent uh, IPL stories from the Hindu paper. So I'm just taking the first paragraph of this news. If I just put it here and then put submit, okay, I hope you can see it. Okay, so yeah, I hope you can see it. Okay, so yeah, now what you can see in the top left corner, so I have not when we put the text snippet, there are no annotations available in the sentence, but after running the thing, now you can see in the sentence there are annotations, automatic annotations. So what are these annotations? Basically these are the mention detection. So they are detected what are the individual entities in your text. Okay, now you can see, so what they are identifying, so all these things are underlined. So India, Royal Challengers Bangalore, Harshal Patel, Indian Premier League, South Africa, RCB, Fab Duplessis. So all these things, T20. So all these things they have identified, and you can also get their part of speech. If you just see the color codes, so the verbs are with green, nouns are with this orange or saffron, what I don't know. So and this adjective is like with purple, adverbs with this euros. You can see what according to that they have colored those entities. Okay, now if you just remember what are the next steps. Now for each of these words, they connect it with individual so actual page. So they connect it with actual Wikipedia page. So if you just see, so this is the page. So this Indian Premier League. So if you just see, so this Indian Premier League they connect it with. So if you just click, it will show it to the that page. Okay, so now you can see, so this is the Wikipedia page for India Premier League. Okay, now if you just go back. Similarly, let's see for Fab Duplessis. Okay, yeah, you can see. So they already connected with this Wikipedia page. Okay. Okay, so let's see. Yeah. And for India, maybe, yeah. So this India also they connected with this India page. Okay, let's yeah. The thing that I am saying is first they identify the individual entities, then they will generate different candidates, and then among those candidates they take the best one for linking. So if you just see this Indian Premier League, so for this Indian Premier League, maybe they have found this different pages for different targets. Okay, so different targets, and among these all these different targets, so among these all these different targets, they take the best Wikipedia pages. Okay, similarly you can also find for this one also. Basically you can play with all these things. So just check. Yeah, so if you just see for the support for this Royal Challengers Bangalore, so for this Royal Challengers Bangalore, so they have searched for different individual Wikipedia pages. So this Royal Challengers only one pages. So there are Rogers Bangalore, maybe another page. There is RCB. Okay, so for RCB there are other different pages. Among all these suggestions, they have chosen the best one. So which is this? So basically, you can just play with all these things. So you can submit other thing and check. Okay, so you can just put it some other thing and check. Maybe let's give this paragraph only. So I'm just showing you how you can just explore all these tools to do this kind of thing, because without exploring all these things you will not learn much. Okay, so let's see. Again, similarly, if you just see, so I've just given this paragraph. Now from this paragraph they automatically identify the entities Lucknow, LSG, so this thing, then M Chinnaswamy Stadium, and then Bangalore, all these things, and they have identified. But I guess they have wrongly connect this LSG. Suppose if you just check this LSG, yeah, so they are connected with some kind of band or something like that. But in our context, it is a sports team, IPL sports team LSG. So this type of thing can happen. Okay, so this type of thing can happen. Okay. Basically, there is no page with LSG, I guess. Like there are pages with Lucknow Super Giant, but I don't know there will be a page for this abbreviation LSG. You can just check and all this thing. Okay, so this is just for demonstration. You can just check and play with that. So you can also increase the number of suggestion and all this thing by sliding this in the upper right corner. Okay, so this is just a fun example. I thought one will love it, so that's why I just show you. Okay. Okay. Yeah, so these questions are again easy. So what this question suggests, I hope there's a missing part. So maybe it will be it will be can or something like that. Can accurate mention detection and disambiguation system using keyphraseness and commonness. So basically the question they're asking is it like what is the usefulness with this keyphraseness and commonness for this mention detection and disambiguation. So if they are not accurate, then why? So basically they are asking. So first thing is that so what they are saying so no, so it is accurate. So basically no, we know with this keyphraseness and commonness the detection and ambiguation cannot be accurate. But if you remember, with this commonness, only the top connected page will each time this will be only when you are doing the disambiguation with this commonness formula, it will always bias towards the highest linked article. So that's why it is not accurate. So the option A will be wrong. So what is the next question? So it is saying, okay, so no, commonness will always select the most frequent concept for a given mention. Yeah, it is the thing. So why we are not want to use commonness for accurate disambiguation? So commonness will always select the most frequent concept. So B is the correct option. So they are saying multiple option allowed. So let's see what C says. So C says commonness will ignore entities with low keyphraseness. So basically commonness is not related to keyphraseness. So if you just see the commonness formula, so there is no relation between commonness and keyphraseness. So C is not a correct option. So what is option D? So commonness does not take context into consideration while entity. So yeah, this is true. If you just remember, commonness just count the number of times that word connect to the other Wikipedia pages, but it is not consider the late or right context of the particular word. Okay, so this is a problem for disambiguation. So it will always better when you want to disambiguate a word, it is always better to see the context. But without seeing the context, it will be difficult. But in the commonness, there are no way you can check the context. So that's why commonness is not a good way to disambiguate your system. So yeah, so option B and D, I guess the correct option. Okay, so yeah, option B and D is the correct option for this thing. Yeah, you already done this numericals, number 4, 5, all these things I've done. Yeah. Yeah, so if you just remember what is information extraction. So in this question, so information extraction can directly help in which of the following downstream tasks. So basically, if you remember what is information extraction, so given a text, unstructured text, uh, we want to get out, like extract the information about. So if you just see, so what is information extraction for? So suppose let's take this paragraph only. Okay, so let's take this paragraph only. So what is information extraction? So if someone gives you this paragraph, so India and Royal Challengers Bangalore pacer Harshal Patel competed 100 wickets in his this kind of thing and all this thing. Now this is okay. So this kind of thing is fine, but what are the different information that we want to extract from this thing? So one thing is that uh, Royal Challengers Bangalore, Harshal Patel. So what is the relation between Royal Challengers Bangalore and Harshal Patel? That can be information. Okay, so you can extract the thing. So maybe Royal Challengers Bangalore and Harshal Patel. So these are the two named entities, and they are connected by relation player. Maybe Harshal Patel Harshal Patel playing for this RCB. Okay, and also you can also another information you can extract. India Harshal Patel. So if you just see the sentence, India and RCB pacer. So basically the sentence suggests in the Harshal Patel also plays for India. So yeah, so there can be another tuple. So India India player Harshal Patel. Okay, so there is another tuple. So if you see another thing, Harshal Patel 100 wickets. If you just I don't know it will be good or bad, but this is another example. So how many wickets a player can already have, how many wickets this player already had, all this thing. And next thing is that, yeah, so again another thing, so while he is South African RCB teammate, so you can also uh, extract the thing. So Harshal Patel teammate Fab du Plessis, so basically they played for the same team. Another information you can extract, because there is information. So Harshal Patel and Fab du Plessis are teammates, and you know Harshal Patel plays for Royal Challengers Bangalore, so maybe Fab du Plessis also plays for this Royal Challengers Bangalore. Okay. Another information is that South African RCB teammates. So Fab du Plessis plays for South Africa also. So such a way you can, so given a paragraph, there can be multiple information that you can extract. Okay, and you can use that. Uh, you can use it to from different databases, so different knowledge databases. So this kind of text are kind of called unstructured text. But what is structured text? Kind of a table. Okay, so kind of a table. So if you just think of, suppose this is your corpus. So in your corpus there are lots of sentences and all these things, and so this is unstructured. So this is unstructured, but you want to structure it. So then you need to go for this information. So information extraction. So information extraction. So maybe for in our case, so what we have already extracted. So Harshal Patel plays for India. So this is one of the information we have got. Second is Harshal Patel plays for RCB. Okay. Then Fab du Plessis plays for RCB. Okay. So then Fab du Plessis plays for South Africa. Okay. Similarly, Harshal Patel uh, teammate Fab du Plessis. So these are the different thing you can extract from a unstructured corpus, and this can be a structured thing. So you can query from here also. If someone asks, so if you can use it to form a question. So which country Harshal Patel plays for? Then you can say, okay, India. Similarly, which country Fab du Plessis plays for? You can say it is South Africa. You can say which club Harshal Patel plays for. It will be RCB. So you can. I hope you get the point. So basically, this is an unstructured text, and from this unstructured text, you are extracting information, and from this information, you can query it directly. So, okay. Yeah, so if you just see, so what they are asking, say, if for such kind of information extraction framework, so in which of this following task, downstream task, you will get help from? So automatic knowledge based construction. Yeah, so so if you just see from this kind of text corpus or unstructured data, you can always build such kind of knowledge bases. So basically, these are the knowledge bases. Okay, so there will be a subject, object, and there is a subject object, and it is connected with some kind of relation. Okay, so this can be knowledge base. You can also connect it like a graph kind of architecture. So Harshal Patel is connected with India with some kind of place relation. Similarly, Harshal Patel. So Harshal Patel plays with some for RCB. RCB is connected to India. So there are player Virat Kohli also plays for India. So this kind of knowledge graph you can extract from this kind of all these things. So basically these are the knowledge bases. So you can construct these knowledge bases, and someone asks for something, you can just export the knowledge base, and you can provide the answer. Okay. So this can be helpful. Second thing, entity linking. Information extraction as such not directly help in the entity linking, because the entity linking is a different process. Okay, entity linking is a different process, and information extraction once the information extraction needs help from entity linking, but this in the process of information extraction, it cannot like directly, it is not helping entity linking, but in the process entity linking is needed for information extraction. So number 2 is not the right option. Number 3 is neural machine translation. So yeah, so with this information extraction, there is no direct relation with the machine translation, because when you are extracting information from a unstructured corpus to structured corpus, there is no relation with this machine translation, such kind of thing. Okay, so number 3 is also not right. But yeah, so but the question answering is benefited by such kind of information. How? So if someone gives you this kind of structured database, so you can easily question answer that we already discussed. So given this subject and object, you can form a question, and so given a subject and this relation, you can form a question, and the object will be the answer. Similarly, the object and subject will be a question. Object and relation will be a question, and subject will be answer. Some kind of thing you can do. Similarly, you can traverse the graph and provide the answer. Maybe there will be, so if someone asks if Harshal Patel and Virat Kohli related by something, then you can, if you traverse such kind of graph, you can find, okay, so there is a relation between Virat Kohli and Harshal Patel through India. So this kind of thing can be possible. Okay, so yeah, so number 1 and number 4 is helped like they are helped by this information extraction framework. Okay, so information extraction helps knowledge based construction, and this knowledge based construction basically help this kind of and question answering. Okay, yeah, so number 1 and number 7. So what are the drawbacks of hand built regex pattern for relation extraction? This thing I don't want to discuss. Basically, what are the drawbacks for, if you remember? So if you want to so what is this relation extraction? So what is this relation extraction? So if you just want to recap, so suppose there is a sentence ki New Delhi is the capital of India. See, if someone gives you this sentence and you want to extract the relation, so basically what are the relations? So suppose someone marks New Delhi and India, and they want to identify the relation between those two. Then your relation extraction system will provide you this tuple. So New Delhi capital of India. So basically this is your relation extraction thing. Now in this question, so what are they asking? So what are the drawbacks for hand built regex pattern? So how people use this hand built regex pattern? So so maybe there are similar kind of sentence. So New Delhi is the capital of India. Maybe Kolkata is the capital of West Bengal. Okay, so Kolkata is the same pattern. So Kolkata is the capital of West Bengal. Some kind of the pattern is same. So what is the pattern? So the subject. So then is the capital of an object. So this is the pattern. So if you want to extract the relation, if you just see the pattern. So if in a sentence the format is kind of same thing. So suppose you want to match this pattern with some sentence. So if you just check, okay, so suppose you find another sentence, maybe Dhaka is the capital of Bangladesh. Such kind, then what you can do is that, like, if you just match this hand, so basically this is not a kind of, I'm just giving an example, so similar to regex expression. So you just match this expression with this sentence, you can say, okay, so Dhaka is matched with this thing and Bangladesh is matched with this thing. So and in the between part is matched with this thing. So basically if you just if this match with this regex thing, so then you can say, okay, so this is a relation. So this is a relation. So between Dhaka and Bangladesh, this is a capital of relation. Okay.
So do we need to like manually define the regex pattern for all this?
Yeah. So basically this is the problem. So what in this question they are asking, no one does this kind of thing nowadays. So basically if you just remember what is bootstrapping in such cases, so bootstrapping all these cases, they use this kind of hand built regex pattern. So for a particular relation, so suppose this just consider this example only. Suppose the relation that we are interested in, capital of. Okay, so what you can do is that for this capital of relation, suppose someone gives you 100 sentences. Okay, so someone gives you 100 sentences for capital of with this capital of relation. Then what you can do is that you study all these 100 sentences and find a common pattern. Okay, so maybe this kind of pattern you can find. So subject, this is capital of something. Then maybe you can find another pattern. So subject, object is capital of subject, some kind of thing. So if I understand, so now you already have this pattern, and now you use this this pattern, and you use this pattern to find the relation in some other unknown corpus. In some other unknown corpus, you just use this expression and match, okay, for each individual sentences. If some sentence match, then you will, okay, so then you will think that, okay, so in that sentence capital of relation present, and the relation and the subject and object is this and this. So this is the thing. Obviously you need to hand build the regex pattern from this. So but yeah, so but in the beginning someone need to give you some of the example sentences. Okay, so this is the thing. Similarly, suppose the another example, maybe played for, maybe there is a example relation called played for. Okay, so maybe the pattern of such kind of sentence is that maybe Saurav Ganguly played for India, some kind of thing. And if someone gives you like 100 such kind of sentence, maybe Saurav Ganguly played for India, Sachin Tendulkar plays for this Mumbai Indians, some kind of format like this. So after studying all these 100 200 example, you will find a common pattern, maybe 2 or 3 common pattern. So then you use this common pattern. So these are your hand built regex expression, and then you use this regex expression to find the relation on some unknown corpus. This is the thing. So, but if you see in your question, so what they are asking is that, like, what are the drawbacks? So obviously, if you see, so what is the drawback? So low precision. Obviously, this is a drawback, because like you are only, so you are, suppose you are just hand build this kind of regex pattern, but how you do this kind of hand built regex pattern? So you are studying 100 example and you are doing this kind of thing. But what if there are other patterns to represent the same relation? Okay, so then if you just only believing this kind of hand built regex pattern, so there are cases when you will fail. Suppose you will only know, so suppose I'm giving an example. Suppose a relation called capital of, and for capital of, after studying all this 100 or 200 example, you are finding maybe 2 or 3 hand built regex pattern. Okay, now suppose there are another 20 ways to express the same relation. Now if you use only these 2-3 pattern, you will like never find those relation when the same relation is expressed by some other patterns. So you will always like this low precision will harm you. Yeah, this will be the problem, low precision.
And the precision will be low, but will the accuracy will be greater? The accuracy, or
so how will you define the accuracy? So accuracy is like, what is the accuracy? So if do you know the definition of precision and recall? So precision is different thing, recall is different thing.
Yeah.
So accuracy will always be hard. Yeah. So accuracy will hard na. So suppose. Okay. So let's see this way. Suppose use search. Someone gives you 100 sentences. You find 3 regex pattern. Okay. For a relation capital of. Okay. Now, suppose there is some oracle, and I know ki there are 50 different ways to represent this capital of this capital relation. Now if someone gives you a corpus, okay, someone gives you a corpus, but in this corpus most of the sentences where this capital of relation presents are among these 47 patterns. So the total pattern is 50, and among this, if you just subtract these three, so there are 47 different patterns. So among most of the sentences are from this pattern only. So then obviously your performance will accuracy will fall, because suppose there is a true example for capital of relation, relation, but using this regex pattern, these 3 regex pattern, you cannot find this pattern will never match with this sentence, and you will never report, okay, so this is a capital of relation. So obviously your accuracy will harm. This is the problem. And so this press low position is okay. Not possible to extend to new pattern automatically. Yeah, obviously you cannot automatically extend to new pattern using hand built regex. Okay. Costly, yeah, costly, obviously costly, uh, because you need to have some kind of human annotator who will sit for you, understand the problem and design the patterns. Yeah, this is costly. And say last, what is the point? So cannot utilize easily available text from large corpus. This is not true. uh, they can use the large corpus. But basically the number 4 point is not a the regex pattern. Yeah, so the first yeah, so IO low position, there is a problem in the options. Number 2 3 is fine. So what is the number 4? Cannot utilize easily available text from yeah, so yeah, that's why I'm saying there is no relation. Yeah, so basically this is the point. So the regex this hand built regex pattern uh, will affect this thing. So this hand built regex pattern are not utilizing this large corpus. Yeah. So in the bootstrap, if you just use the bootstrap thing, in that case you can utilize the large corpus. But and also in the case of distance supervision, you can use the large corpus. But with this hand built regex thing, you cannot use this regex pattern. Yeah, so and the end, so I thought I hope you already know this kind of spicy package and all these things, when you can where you can do this kind of entity identification and then linking. For linking, you can use this GitHub repository, spicy entity linker. If you just go through this thing, this is pretty amazing. So you just load all this thing, and if someone gives you this kind of word, so suppose the word is I was the Pirates of the Caribbean's last Sylvester, and it's if you just pass it to the model, it will automatically gives you the corresponding page. Okay, so if you for this thing, the Pirate of the Caribbean is linked to this Wikipedia page. This so this is not actually Wikipedia, so Wikidata. The page maybe page will be different. Similarly for last Sylvester, so this they are just uh, linking the Sylvester with the Sylvester entity. So it is a Wikipedia entity. So if you just see wiki in Wikipedia, there is a concept called Wikidata. Okay, so Wikidata maintains all the different entities. Okay, and the Wikipedia is the documentation. Like if you find if I can show you, suppose I don't know if I can show you. Suppose let's check Saurabh Ganguly, and let's find it here. Yeah, so this is the Wikipedia page for Saurabh Ganguly. Okay, but if you want to see the wiki data behind that, I don't know how nowadays they show this. Previously there is a link from where you can see all this thing. Okay, so let me check Wikidata link. Yeah, Wikidata. Yeah, so these are the Wikidata item. Basically, uh, if someone wants to link Saurabh Ganguly, if there is a corpus involving Saurabh Ganguly, it will be connected to this Wikipedia entity. So this is the mention detection. So it will first detect the mention, and then after that it will disambiguate. Now if you just see in this entity, so there are different links. Okay, so there are different links. So Saurabh Ganguly, sex, male. Saurabh Ganguly, country of citizen. Basically, these are the tuples. So these are the relations. Saurabh Ganguly, country of citizenship, then India. Saurabh Ganguly, country of sports, India. So these are the example that I already shown you earlier. So these are the kind of tuples that's extracted. So given name Saurabh, family name Ganguly, this kind of thing, date of birth. So these are the relations. So date of birth is a relation, and Saurabh Ganguly is related with this cardinal with this date of birth relation. Similarly, place of birth is a relation. It's connected to the Saurabh Ganguly connected with Kolkata with this relation. Sibling. So Saurabh Ganguly connected with Snehasis Ganguly with the sibling relation. So all these things, our spouse, language. So you can find all this thing by this. So so when how you can search this thing. So you will go to a Wikipedia page, and in that Wikipedia page you can in the toolbar you can find Wikipedia item and you can search all this. So basically this this thing will link to this kind of entity linkers. So basically these are the entity linkers. Okay. You can also do it with this spicy library. Yeah. So if I have already run it once. So if you just import this spicy and this package, and in this I have put a same this I hope yeah. So I put this paragraph here only. Now if you just see it already predicts. Okay, so India is a GP. So these are the terminology for spicy. So basically there are different type of named entities. So these are the different types. So GP or organizational, basically the organization. So GP basically location. It's uh, related to the location kind of entity. RCP again an organization. Harshal Patel is a person. 100 is a cardinal. IPL is an organization. Monday is a date. This kind of thing you can find. Okay, and you can also see what is this this different legends mean. So you can just type spicy explain org. Suppose you don't know what is the meaning of this GP, you can just write it GP and you can just run it. Yeah, it will showcase countries, cities and states. Okay, so such a way you can check it. You can similarly you can find it what is not. So these are good practices. You can just took some of the example and just check what are the different thing and how things work and all these things. So you can see, so what is this not? So nationalities or religion or political groups and like that. Okay. So because you can see nationalities. So this is South African. So that's why it is saying not. If it is just South Africa, maybe then it will give you GP only. Okay. So this kind of tags, and you can also color code like if, for visualization purpose you can use this thing. So it will color the different named entities with different kind of colors. So GP will be different color or ORGs will be different colors. All the same similar type of entities will be similar color, and all these things will be different. Okay, so basically you can use this. So there are three things that I have talked to. So this Wikifire thing, you can just play with this Wikifire fire. It is very exciting. You can check how this individual words are mapped to different Wikipedia articles. Then this this page spicy entity linker, how it will link to different Wikipedia entities. Okay, and this package. With this package, it will not link with any Wikipedia articles, but it will first find what are the different entities, and then there will be the next steps. So in this package, you cannot link with Wikipedia entities, but you can link the different. You can find the different named entities and what are the types for the named for that entity. So are there organization or countries or something like that. Then you can use this kind of packages to link directly link to Wikidata entities, and this Wikifire for this Wikipedia articles. Okay, so you can just explore all these things. So these are fun. So if you just search in the Google, so you will find lots of such examples. But I hope these things are sufficient. If you just see all these things are sufficient. But yeah, The thing is that keep searching, keep doing like practice problems, do small coding. How so? There nowadays there are lots of packages. You don't need to write all these things from scratch. So there are lots of packages. You just want to you just need to know how to use the package. Okay, so how to use the package. So yeah, so you can just take such documents and then do science. You can do some kind of small projects also. Given a code snippet or no, given a new snippet, you are automatically identifying the Wikipedia articles and what are the in a given day what type of articles are more in the focus and all these things. So there can be different project ideas you can think of, but before that, it is good to explore all these packages. Okay, so all these packages and how they work, do small coding. Yeah, so that's all. So this is the thing. So if you have any question, you can ask. Else, yeah, we can meet next week for this.
Arijit sir,
Yeah.
under the problem solving sessions link, you have uploaded only 3 PPTs, 3 weeks PPT.
PPTs. Where? Which thing you are talking
Under
about?
the problem solving session at Swayam website.
Okay, so you are asking about the PPTs.
Yes, sir. Can you please upload all the PPTs?
Okay.
It will be very helpful for us.
So because the thing is that most of the time I just solve this assignment problem, so that's why I thought there is no point in uploading.
No, previous year's questions can help us.
Okay, I can upload. Yeah, but the thing is that start doing this kind of programming problems. It will help you.
Sir, I request you to please upload the previous discussion session, recorded discussion sessions.
I already uploaded all these things till week 9 in YouTube.
Okay.
Yes, sir. Link is available under the
discussion session, sir. Discussion session lectures.
Yes, ma'am.
Delivered by you. Uploaded.
Yeah, the others can comment. So I think I already uploaded all the discussion sessions recording till week 9. So others, can anyone other than this Sony ma'am, can anyone confirm that?
Yes, it is available there.
Yeah. So that's
Thank you,
ma'am, you can just search it and you can find it. It's already available.
Arijit sir, you will
PPTs as soon as possible. Sir.
What?
PPTs.
Oh, okay. I'll yeah. Okay. Thank you. Okay, then thank you. If you don't have any further doubts, so we can meet next week. Week 11.
Okay, thank you so much, sir.
Thank you, sir.
Thank you, sir.
Welcome.